Okay, here are the rest of the ratio test homework solutions, or at least most of the rest. You'll see what I'm talking about in a minute, but here we go. The ratio test on number 31. The limit as n goes to infinity of the n plus first term, so e to the n plus 1 over n plus 1 factorial, divided by or multiplied by the reciprocal of the nth term. So we're going to simplify this. E to the n plus 1 over e to the n is just e. N factorial is everything 1 times 2 times 3 times 4 up to n. N plus 1 factorial is everything 1 times 2 times 3 times 4 up to n, and then one additional term times n plus 1. So all those terms cancel with this n factorial, except for that last term, n plus 1. This limit is a constant over this first degree polynomial, so we know it's going to be 0, and that is less than 1. So this has absolute convergence. And we're on to the next one, number 33. Number 33 is going to be very complex because of this n plus 1 to the power of n. I already looked at that one, and that's going to take a while to actually calculate that limit. So I'm going to skip that, put that under a separate video. You'll see why when we get there. So let's skip to 35. 35. We'll take the limit as n goes to infinity of the absolute value of the n plus first term multiplied by the reciprocal of the nth term simplify it as much as possible until we can calculate the limit. 5 to the n plus 1 and 5 to the n, easy. 2 to the n plus 1 and 2 to the n plus 1 plus 1. Not so easy because they're exponential functions. What I'm going to do here is I'm going to use the old strategy of we'll divide by, how about everything by 2 over n plus 1. See what happens there. So on the top, I'm going to take this part and divide that. So we'll have 5 times 2 to the n over 2 to the n plus 1 plus 1 over 2 to the n plus 1. And the bottom, we're dividing everything by 2 to the n plus 1. So I have 1 plus 1 over 2 to the n plus 1. So we have the limit as n goes to infinity of 5 times the quantity 1 over 2 plus 1 over 2 to the n plus 1 over 1 plus 1 over 2 to the n plus 1. Now when we apply the limit as n goes to infinity, we have 5 times 1/2 plus 0 over 1 plus 0, which is 1. So this equals 5/2, which is greater than 1. So this diverges. Last one. the n plus first term. And remember, this is absolute value, so we can ignore the negative 1 to the n plus 1. This bottom is not a factorial. Be careful. It's 1 times 3. It's all the odd numbers. So the next odd number would be 2 away from 2n plus 1, which is 2n plus 3. Now, you could also look at it this way. If you plug in n plus 1 to that term, that would produce 2n plus 2 plus 1, which is 2n plus 3. But I just want to show it so it is, you can see it does end, and it's going every odd number. And that would make sense here. Now we have to multiply it by the reciprocal of the nth term, which is all these odd numbers multiplied by each other again, but until you get to 2n plus 1 over n factorial. So you can see what happens for those odd numbers down on the bottom. Everything cancels except the 2n plus 1, 2n plus 3 on the bottom. For these factorials, everything cancels to the n factorial, so you're left with the n plus 1, the remaining term up there. This limit is equal to 1/2, which is less than 1, so this converges. Absolutely. So that's it for the homework. We are going to get back on a separate video to number 33 and have a look at that.